Hey everyone, welcome to Flutter for Makers. I am so excited all of you guys are here. This talk is going to be bonkers. I've got so much stuff to show off to you today. This is something that I am super passionate about, and I am excited to have the opportunity to share it with all of you. So before we get started, I'm sure most of you are wondering, who the heck is this guy? If you didn't like this picture of me, there's another picture of me up there, right? I've been developing in Flutter since 2019. Shortly after the 1.0 release, I got started. I've been obsessed with Flutter ever since. I absolutely love it. It's my favorite thing to program in. And currently I work as a senior mobile developer at Aloya Corporate Federal Credit Union. I know we've got an international audience here, so if you don't know what a credit union is, it's basically a bank that is owned by the people that bank there. But my passion is I am a maker and an artist, and most of all, I'm another guy with a YouTube channel, so like and subscribe, everybody. All right, but let's get into today's topics. The first thing I'm going to cover is stuff that I've made. I've got a small sampling on the table here for you, but I've made a bunch of stuff that I'm excited to share with you. Second thing we're going to talk about today is Flutter plus Arduino. So if you want to use an Arduino with your Flutter project, how do you do that? By the end of this talk, you're going to know exactly how to do that. Third thing we're going to talk about is Flutter and Raspberry Pi. Super, super exciting field. If you're interested in anything having to do with Flutter embedded, we will 100% be talking about that. And then, fingers crossed, we'll have time at the end for a little bit of Q&A. I'm excited to get your questions and give you some answers. So, let's get started. First thing I want to show off is a thing I made called the Decisionator. Who here has trouble figuring out what to have for dinner? Who has the argument with your partner about what you're going to have for dinner? Yeah, that's 100% me. I invented a machine to fix that problem. It's called the Decisionator. And basically what you do is you hit a button, it goes through the restaurants, and it decides what you're having for dinner. So let me just show you a quick video of what that looks like. Looks like we're having IHOP for dinner, guys. Yay! That does not deserve an applause, but thank you, I appreciate it. It has a couple of other modes as well. It has a chore mode, if you can't decide what chores you guys want to do. It has a date night mode, if you can't figure out what date you want to go on. And it has streaming service mode, if you can't figure out what to watch at night, right? So it's silly, it's stupid, but I love it. Next invention that I want to show you. This is not exactly what we're talking about today, but I do paint miniatures and I love doing it. I'm sure all of us know someone who has a tablet laying in a drawer somewhere that's not being used, right? It's essentially e-waste, right? And I was thinking, what can I do with one of my old tablets that I could repurpose it so it doesn't end up in a landfill? So I came up with this idea of creating a miniature display case. It's got a slot in the back for a tablet, and then I wrote a small Flutter app called Backdrop Box. And so what Backdrop Box does is it allows you to choose a custom background for each of your minis. And yeah, if you want to make one of these yourself, I've got instructions on how to do it on my blog. So definitely check that out. It's all parametric, so you can design it for your own tablet. And the app is free on the App Store. Next one I want to show off is called Flip Puck. I grew up with my misspent youth in the arcades. And I feel very lucky to have spent my misspent youth in the arcades. My dad took me to the arcades when I was a kid. My favorite thing to do was to play air hockey with him. Loved air hockey. And after I spent, I had $5 I could spend at the arcade. After I spent $2.50 on the air hockey, I would spend the other $2.50 on pinball, okay? So Flip Puck is a combination of air hockey and pinball. And that's what this little bad boy is right here with the blinding pink light. I'll just give you a quick demonstration of what a Flip Puck game looks like here. So you've got two teams and you're trying to bat the puck to the other end of the arena. And yeah, there's some glass bumpers there that break after the puck hits it 3 times. And after it gets to the end, yeah, a point is scored. First person to lose 3 of their lives is the loser. So yeah, this is super fun. I had a lot of fun making this. I don't have a video up for this one right now. I'm hoping to get it up on my YouTube channel soon because the story of creating this thing was wild. All right. This thing is running, by the way, both the Decisionator and Flip Puck are running on a Raspberry Pi. It's running on a Raspberry Pi B4 8 gigabytes, 4B 8 gigabytes, sorry, I transposed that. And yeah, it's using the Flame Game engine. Both of these are using the Flame Game engine, and they're running on FlutterPy, which is a engine embedder for Linux that will allow you to run Flutter applications from the command line. We're going to be talking more about that in a minute. That is dope as heck. All right, demo number 1. The first demo is my big blue button. Can anyone guess why it's called my big blue button? Because it's big, it's blue, and it's a button. Yes, all right. So what I'm going to do is I'm just going to go ahead and pop out of the PowerPoint presentation here. I'm going to plug the big blue button into my laptop, and I'm going to launch the Flutter Fortunator app. Now, ever since I played Curse of Strahd with my D&D group, I've been obsessed with fortune-telling techniques, all right? So tarot cards, coins, fortune cookies, any type of fortune thing I've been obsessed with. So I created the Flutter Fortunator. Is there anyone in the audience who's brave enough to come up, hit the button, and have their Flutter fortune told? Anyone? Yes, come on up, we have a winner. Give him a big round of applause. All right, my friend, just hit the button. We're finding your Flutter fortune. Let's see what it is. The widget you seek is already within you and on pub.dev. Give them a big round of applause. Thank you so much for coming up. All right, so I just want to recap what just happened there for a second. All right, I hit the button. There's these LED lights that turn on, okay? When I hit the button, the LED lights turn on, the Flutter Fortunator kicks off, and then at the end of the cycle, the lights turn off. All right, so let's just hit that again. Lights turn on. Fortune is coming up. By the way, I generated all of these on Google Gemini, so let Dash be your spirit animal. Cute, helpful, and surprisingly fast. Yes, all right. Yeah, I had way too much fun with this thing. There are 20 individual Flutter fortunes that this thing can trigger depending on what you hit. So I could stand here pounding the button all day, but I'm sure that you want to understand how the big blue button works. So let me go ahead and unplug that from the USB port and pop out of Flutter Fortunes, and I am going to hop back into my presentation from current slide. Yes, all right. So, how does this work? How does this work? Yeah, so these pictures were all generated by Gemini. The last one, I don't know if you noticed it, the soldering iron was weird as heck. This one, Dash stuck a screwdriver at a breadboard. Don't do that, guys. Please, don't do that. You'll electrocute yourselves. How does the big blue button work? The answer is through the magic of serial communication. You know, breakfast really is the most important meal of the day, and if you don't have a good breakfast, none of your fortunes are going to come. No, I'm sorry. My wife told me that I should delete that slide. I didn't listen to her, and now I'm having regret. But the entire rest of the presentation is it was great, all right. The entire rest of the presentation is downhill from there, guys, so sorry, that's the high point. No, the answer is serial communication. So you saw me hook this up via USB. The S in USB stands for serial, universal serial bus, right? So these packets are less grain and sugar based and more digital based, but essentially what happens is I hit the button and there is, surprise, an Arduino in this thing. So the Arduino is just sending the word activate over to the Flutter Fortunes app. That kicks everything off. The Flutter Fortunes app does its thing, pulls up a random fortune, does all the stuff. As soon as it's done, the Flutter Fortunes app then sends the word deactivate back to the button, and that is its signal to turn the light off. Okay, so let's dig into this a little bit more because that was a super high level explanation of what's going on. So let's show you guys a schematic. If you've never seen a schematic before, don't freak out. It's actually way easier than what it looks like. It's super easy. So an Arduino has a whole bunch of pins on it, okay? And those pins allow us to do things. They allow us to receive inputs. They allow us to send out outputs. So what is this happening? Well, on the pin D2 in the upper left-hand corner here, we have the push button. So this push button right here is attached to pin D2 on the Arduino. The other end of the push button is attached to the Arduino's ground plane. Now over on the right, we have a barrel jack. So if I've already got power coming in from the Arduino, why do I need 12 volts of power coming in from my power strip over here? The answer is, if I tried to draw all the power that these LEDs need to run from an Arduino, I would burn out my Arduino. Also, the LEDs run on 12 volts, the Arduino can only put out 5. So, I have a separate power source that allows me to get that 12 volt input. So, this little triangle right here, that's the schematic symbol for an LED. That's just these LED strips that are running around the top and bottom of my Flutter Fortunator button. And then we've got this little circle right here. That's just a transistor. Now, a transistor is just a switch. It allows you to control a high voltage with a low voltage. So, pin number A7 on my Arduino Nano is going to put out 5 volts to this transistor. When it receives that 5 volts, the transistor is like, oh, okay, time to turn on, and it allows the 12 volts coming from the barrel jack to go through the LED. So that's how we control the LED being turned on or off. Basic transistor logic 101. The only thing that is somewhat confusing is I've got a resistor right here, and I want to comment on that briefly because we are all developers. We are used to the world of binary. Zeros, ones, on, off, true, false. The real world does not work like that, guys. The real world is more like, somewhere in between, right? So if you get like electromagnetic frequency from your microwave or your Wi-Fi or your Bluetooth or a static charge that hits this transistor, it can turn on prematurely because it detects a voltage that we don't actually care about. So what this resistor is doing, it's called a pull-down resistor. And what a pull-down resistor does is it drains the line of any unwanted voltage that we want. So the only voltage that we detect on the transistor is the voltage coming from the Arduino Nano, not from any other sources. All right. So now that we've got a brief overview of the schematic, let's go ahead and take a look at the code. This is just C code, guys. If you've written in Dart, you understand C. Dart is a C-based language, okay? I'm oversimplifying it a little bit, but you guys will be able to figure this out. So what is this doing? First off, we're defining our pins. We're saying that the Arduino, we're using pin 2 for the button, pin A7 to turn on and off the LED lights. We're also setting up some basic state, and we're defining what those pins do. So down here, we set pin modes. So we're saying that the button pin we are going to use is going to be treated as an input, and we're choosing the light pin as an output. Also, you might see the word pull up here. A pull-up is the opposite of a pull-down, all right? It's the same logic, only you're pulling the voltage up instead of draining it down. Okay, next slide. So what are we doing here? Well, this is just a basic C loop. We're listening for a button press. When we hear the button press, we're going to turn on the light. That's what this digital right here is. It says digital right, light pin high. What that means is we're sending a voltage to that transistor that I showed you earlier that allows the 12 volts to go through that turns on this LED strip right here. Cool? And then the last thing we're going to do is we are going to listen for a serial update, because remember, sending the word activate is only half of the equation. We want to be able to turn these lights off when the Flutter Fortunator finishes. So we are going to listen for a serial update. How are we going to do that? With this little ditty right here, right? We're just going to listen for the word deactivate to come in from the serial port, and the moment it does, we are setting the light pin to low, which means we no longer have the voltage going through the line. That in turn is going to turn off the LEDs, we reset the state, and we re-enable the button so that another fortune can be read, thus completing the circle of the Fortunator life. Now, that has all been Arduino. We are not at an Arduino conference, are we? We're at a Flutter conference. You guys want to know the Flutter side of this. You're all bored. I'm like, yeah, show us the Flutter, woo. Okay, so Flutter, the simplest way to do this is through a package called libserialport. We have had 2 talks talking about platform channels and how to communicate with stuff. This is a package that uses that logic. So Flutter libserialport is just a wrapper for the libserialport C library. It works on pretty much everything except for the web and iOS, right? It works pretty much on anything except for those 2 things. So you can import this thing, and bada bing, bada boom, bada bob's your uncle. You have instant serial communication abilities inside of your Flutter app. This thing is super, super easy to use. Let me show you. Okay, so big blue button in Flutter. This is just a Riverbod provider, and what it's doing is we're first off doing a query for all of the serial ports that are open on the device. So my Windows laptop has several serial ports that are available for use. What we're looking looking for right here is this thing. Now, your mileage is going to vary depending on what this is. I have the finest Arduino Nano knockoff from AliExpress, and this is how it's identified as the product name. Your Arduino that is sold by Arduino, produced by Arduino, and it says the word Arduino on it, will probably have a different identifier, all right? So you're gonna need to go through, take a look, figure out what the identifier for your Arduino is when it's plugged into your USB port, and that's what you're going to look for here. So, first thing we're doing is we're using this provider to grab the port, figure out where it is, and so we can know what port that we need to listen to. All right, next up, this is another RiverPod provider that we're going to use to open up serial communication. All right, very simple again. We have our port from the previous provider. We're going to open up reading and write. We're using a baud of 9600. Doesn't actually matter what the baud rate is. It's just, I picked one. And then the important thing here is we set up our reader, and we're going to get a stream from the package. Now, a Dart stream, that's a whole other topic. I'm not going to get into that here, but basically we're listening to a stream of data coming in from the serial port. So when we do that, the important thing is this function here called process incoming data. So what we need is something called a buffer. Because if we just take the data coming from the serial port and yeet it into our code, you know what's going to happen? It's going to be a mess, because we're going to get the letter A, and then maybe the letter CIT, and then maybe the letter I, and then maybe the word bait, right? Because it's coming in one character at a time. So, to make sure that we have the whole package, we need to set up a buffer, and that's what we're doing right here. We are looking for the end of the line, so we know that that's from the new line character that we have right here. And then we're just going to keep adding all that stuff into a buffer. Once the buffer is complete, then we dump the completed message into another stream that we're sending into our Flutter app. Now, why am I using two streams instead of just the stream transformer, right? I'm guessing a lot of you are asking that question. Simply, A, this is a small example. B, this is it's very localized to the state of the provider that we're doing here. And C, frankly, we're not reusing this transformer code anywhere, so I didn't care. But if you are reusing it and you're going to do something at scale, you probably should use a stream transformer as opposed to me just pulling it out of one stream and dumping it into another. And then last but not least, how do we write data back to the Arduino so it knows to turn off the light? It's just this little ditty right here. We're just going to write whatever we pass into the function argument there back to the Arduino, and it has, we already looked at the code, that it listens to it, and thus the circle of life completes. That is digital output in a Flutter app. But next question, how do we do analog input? And that's where my second demo today comes in, the twisty dial. All right, so let me just hop out of my PowerPoint here real quick and plug in the dial. Don't touch that dial, except I need to for this presentation. Get the USB orientation wrong a couple times, open up the knob demo. Now, I did not get a chance to complete this demo, but you'll see that we've got a familiar looking blue bird there. I've got a knob in my hands. Ooh, ah, ooh, ah. This was gonna be Flappy Bird. That's what the goal of this was. This is one set of collision detection and some pipes away from being Flappy Bird, but with a knob instead of just like tapping the screen, right? So that's what the goal was. I ran out of time. This is a fun little demo, but the question is, this is not just an on-off state. This is a variable resistor. How does this work? Well, I'm glad that nobody asked, because you're gonna find out anyway. Let's go back to the PowerPoint presentation. From current slide, yes, and let's go ahead and unplug that. All right, so this is a variable resistor, also known as a potentiometer, also known as, frankly, just a knob. All right, so what happens, let's go ahead and start with the schematic here. In the upper right-hand corner, you're gonna see what one of these looks like underneath the hood. You'll notice that it's 3 prongs. One of those goes to 5 volts. One of those goes to ground, and then the middle one is what's going to go to your Arduino pin that's going to give you a reading. Now that Arduino pin is going to receive a set of numbers. It's going to be either 0, somewhere between 0 or 1023 inclusive, okay? So what we need to do is get that number for where the knob is currently at into the Arduino. So this is really simple. Like I said, the schematic here, pin 2 goes to the Arduino, pin 1 goes to the Arduino's 5 volts, pin 3 goes to ground. And here's the code for that. So serial communication works exactly the same way as what the big blue button did. The difference in this one is that we are reading an analog input. So again, values between 0 and 10,023. Now you're going to see this thing here called smoothing samples. Anyone remember like 5 minutes ago when I said the real world isn't black and white and isn't perfect? This thing sometimes doesn't give perfect results. Sometimes it'll be like, I'm at 5, I'm at 6, I'm at 5, wait, I'm at 4, nope, I'm at 5, okay? And when that happens, there's some things you can do to smooth it out on the hardware side, like installing a capacitor, but when that happens, our pixelated dash is just going to go like that really fast, right? We don't want that. We don't want that. So what we're using is something called a moving average filter. So we've set up a group of samples. In this case, I'm using a set of 10 samples. I take the 10 readings from whatever this thing is putting out, I average them together, that's the number I send back to my Flutter application. What is the benefit of that? Well, because the average is always going to be hypothetically the same or really close to the same. So that means that I don't get my bird having a seizure in midair, it just works, right? And then the other thing is, for my sanity, I don't like seeing values between 0 and 1023. I want values going from 0 to 100. That's just the way my brain works. So this function right down here is a C function called map. All we're doing is saying, take whatever it is from 0 to 1023, remap it to a value range between 0 and 100. And that makes life so much easier to determine where on the screen I'm going to place my dash. All right, we've talked a lot about Arduino, but I promised Raspberry Pi stuff. I'm not going to go as deep into this because this is a whole 2-hour talk in itself, but as I said earlier, the Decisionator and FlipPuck are both embedded Raspberry Pi projects, so there's some really cool, exciting stuff here. So we're just going to give you a small taste of what embedded Flutter has to offer. First off, I would just want to say the entire embedded community owes a debt to Hennis, or on Ardera as his GitHub name. He wrote an engine embedder called FlutterPi. Now, don't be fooled. It has Pi in the name. This will work on any Linux system. You do not have to use a Raspberry Pi to use this. If you've got a Linux-based system, this thing will do the job. And basically what it does is it is a command line ability. It gives you the ability to run your Flutter apps from the command line. No windowing environment required. You don't have to install GNOME, no KDE, none of that. Runs directly from the command line. Why is this a big deal? Because we're using resource-constrained systems. And we want as many resources available to us as possible, and GNOME and KDE and whatever X window environment you've got are taking up resources. So in a world where you have limited resources, you want to cut off as many unnecessary things as you possibly can. And FlutterPi allows you to run on a bare bones Linux environment. So that is the first part. The second part is, how do we access the Raspberry Pi GPIO? Well, I should probably answer, what is Raspberry Pi GPIO? On every Raspberry Pi, you're going to see these pins along the side, very much like Arduino, okay? And these pins all do different things. And so very much like on the Arduino project, we specified a pin to receive button presses or do outputs or things like that. We have the same thing on the Raspberry Pi. And what's the simplest way to access those pins? Not serial communication, guys, but another package by Ardera called Flutter GPIOD. Now what this does is this allows you to get access to the GPIO without needing to worry about serial communication. And this is, it's just so much, it's a very easy package to use. I'm going to go ahead and talk about that in a minute. But what I will say, big caveat here, the Raspberry Pi's GPIO is digital only, okay? So it can receive button presses and it can do on-offs, but it cannot do something like the knob. All right? If you want to do like the twisty dial thing, you now need to pair your Raspberry Pi with an Arduino to receive that analog input and then send it back. And now you're back to serial communication again, basically. But Flutter GPIOD is a fantastic package for that. Highly recommend that you take a look at it. There's a couple of other packages that do similar things. Ardera's stuff has always done me very well, so I highly recommend that you take a look at his stuff. So this code right here, what is it doing? Well, the first thing we got to do is we got to locate the GPIO chip for the Raspberry Pi, okay? Now this chip name varies depending on the Raspberry Pi model that you're using. So in this case, the pin control BCM2711, I think that is the pin name for the 4. I think BCM2385 is the pin name for the 3. I do not know what the pin name for the 5 is, okay? But you have to pay attention, make sure that you get the right pin. You just assign the pin label right there. From there, once you've got the chip, now you're down here, you just have to choose a line. By the way, this is decisionator code, so that's this thing right here. That's why I've got a spin button and a mode button. Basically what you're going to do is you're going to specify which line you want to interact with by looking at chips.line and then configuration and all that good stuff. And then when it comes time, this is how you listen for line input. So essentially we've got the line that we specified back here in this line of code right here. And now we're basically just listening to it. So this is just listening for a button press. This signal edge.following or signal edge.rising, that is just like, does it trigger on button down or when the button comes back up? And then on the event listen, we're just triggering whatever code we want. So I've got this on push function here. You can imagine that that function can do whatever in the world you could possibly want. So that is how you get access to the GPIO on a Raspberry Pi. Now the other side to Flutter Embedded that you need to pay attention to is the Linux distro that you use. Technically, any Linux distro is going to work. If it'll run on a Pi, you can probably get it to work and do what you need. However, with that said, there's 2 that I'm going to recommend, and it depends on what approach you want to take. Approach A is that you start with a fully functional Linux system, and you start turning services off that you don't need. So you just search for like none of my stuff uses Bluetooth, so I turn off the Bluetooth service. You know, you just keep going through it and you're like, okay, look at all these services that I'm not using, turn them off, it gives you resources back, makes things speed up, boot up faster. The alternative is something called build root. Build root is cool, guys. Build root, you start out with nothing but the barest of barest Linux kernels, okay? You start out with a bare bones Linux system, and then you just add the packages and dependencies that you need in Linux to do what you want to do. So if you need Bluetooth, you turn it on, but it's not turned on by default. Build root also supports FlutterPy out of the box. So when you're going through the build root menus to decide what you need and don't need, you can just turn FlutterPy on and you're going to get a working FlutterPy command line from the beginning by using build root. Downside is, if you're like me and you use some funky audio stuff, then you have to like turn on additional dependencies and it requires a lot more tweaking. But you can get a really nice result by using build root. I highly suggest that you check it out. So, I have no idea how much time that was. I felt like I sped through that. But I'm going to go for questions here in a minute. But before I go to questions, I do want to close with one thing. And that is, guys, I love making. I absolutely adore making. And if you are someone who attended this talk and you also like making stuff, or you want to make stuff, I would love to connect with you. So I came up with this idea the night before the conference. I've started a Discord server. If you want to hop in there and just like, we can talk about stuff that we're making, talk about stuff that you want to make, ideas that you have, I don't care what, feel free to join that and hop in. The other ways to reach me are over on the side. I'm on Blue Sky, you can find me on LinkedIn. The GitHub at the bottom contains code for a lot of the stuff that we talked about today, as well as the slide deck. And of course, I am a YouTuber, like and subscribe, guys. But with that, I'm just going to go ahead and open it up. What questions do we have? If you have questions, there's a microphone right there in the middle. So please grab the microphone and shout into it like you're a rapper.
Hello.
Hi.
I have several questions.
Go for it.
First one is, have you tried running FlutterPy on a Yocto distribution?
I have not. It should work. The documentation goes into a lot of detail of how to set everything up, but I cannot give you a good answer on that.
All right, cool. I will send you a repo I just found.
Excellent.
The second is Hannes is our coworker, and we want to know if you have any feedback about things that we can improve about FlutterPy, or anything you think that's missing.
Oh gosh, okay, well, so first off, tell him I said hi, and more importantly, tell him I said thank you, because it's an incredible setup. Things I would Things I appreciate, let me start there, is he has always been very quick to respond to GitHub issues. So whenever I've had a problem, he's been on top of like responding, and I have had a few times where I've had to go ask questions. I would say the biggest opportunity for improvement is not necessarily with FlutterPy itself, but the FlutterPy setup on build root. There are some things that don't necessarily, I feel like the documentation could be improved upon in some issues that I ran into, and I could totally probably write that documentation and should, but like, if that would be like the one thing I would say for improvement. Another thing I appreciate is it used to be very much that you know, you needed to not build on the Raspberry Pi, and now you can do that from what I understand. So yeah, I don't have a lot of feedback other than documentation for dealing with build root, because I feel like the marriage of FlutterPy and build root is a match made in heaven, and I feel like there's a huge opportunity there.
I forgot my last question.
Awesome, thank you so much for the question. Any other questions before I dab out of here? Or dip out of here, I don't know. I try to sound cool and I'm not. Going once, going twice. All right, guys. Thank you again so much for coming. Please reach out to me. I want to see what you guys make. Have a wonderful day. Thank you, guys.